Hello everyone, myself Professor Chavan. We have started the fourth chapter from our 11th Science CBSE board for our subject physics. Okay, so we have learned about what is the projectile motion, how the vertical projectile motion is done, and in today's lecture we are going to learn about the horizontal projectile motion. Okay, horizontal projectile. So, which are the examples of a horizontal projectile motion? How we can say that the object is in horizontal motion? Okay, suppose you are standing on your home gallery and you have to throw one object. If your brother is in a parking area and you have to throw one keys of that bike, then in that case what you are doing, you are just throw that keys from the gallery. Then what is happening there, that keys are not going like this straight line, but what they are doing, you are throwing like this. You are throwing like this. So what is happening there, the object is following this. If you are at this gallery region, okay, from this position you are throwing the key and your brother is at this location, then he will get the keys at this location. Okay, that is, you have to, the keys has to follow some path. Okay, key has to follow some path, and after following that path the keys will reach at this particular ground. Okay, the key will reach at this particular ground. So in this case what is important, that which path is followed by that particular keys, or which path is followed by this keys. Okay, so the motion of the keys is nothing but the horizontal projectile motion. Okay, motion of the keys is, here is the horizontal projectile motion. Whenever we have to throw any object in a direction of a gravity, then in that case that object follows the horizontal projectile motion. Suppose you have to throw a ball from the terrace on the ground, then what is happening, that when you throw the ball, it is initially at the rest. Okay, it is initially at the rest, and when you throw the ball, what is happening there, the ball will drop down on the ground. So at that time, if you look that initially if you throw a ball, due to the acceleration due to gravity acts on that ball, and the speed of the ball increases, the velocity of the ball increases. Okay, so that concept we have to learn in the horizontal projectile. Why there is a change in the speed, why there is an increase in the velocity. Okay, so for that purpose we have to go for the horizontal projectile motion. Okay, so suppose the aeroplane is traveling, then what is happening, the aeroplane is traveling only a horizontal path. Okay, when the aeroplane is traveling here, suppose the aeroplane is traveling, then in that case the aeroplane is traveling some horizontal path here. Okay, and from this aeroplane, suppose one object is dropped. Okay, one object is dropped, what is happening, if you throw a object from the aeroplane, then it will follow this path. Okay, it will follow this path. So when the object is thrown at that time, if the time we consider, at that time initially the velocity of the object is equal to 0. Okay, initial velocity of the object is equal to 0, and it will try to maintain the velocity equal to the velocity of the aeroplane. Okay, it will try to maintain the velocity equal to the velocity of the aeroplane, but its individual velocity, initial velocity, will be equal to 0 at time t equal to 0, and once within a fraction of second, what will happen, its velocity changes. Okay, its velocity changes and it will fall down on this ground. Okay, it will fall down on this ground. So we know that when, in this case we have learned that when the object is thrown, in that case we have learned in the projectile motion that this is the y and this is the x. Okay, this is the vertical direction and this is the horizontal direction. In that case, if it is having some velocity, suppose u, okay, then its horizontal component is, it is making angle theta, its horizontal component will be u cos of theta, and vertical component will be u sine of theta. Okay, u cos of theta and u sine of theta. So in that case, what is happening there, that we learned that as the y component of the velocity changes continuously, in that case the y component, the value of the y component changes continuously with respect to the time. But if we think about the x component, we come to know that the x component remains constant throughout its projectile motion. Okay, so you can consider the x component at this location, at this location, at this location, or at this location. It will be remains u cos of theta. Okay, it will remain u cos of theta, and in this case the component u sine theta changes. Okay, so whenever we have to go for the study of a projectile, one thing we have to remember that the horizontal component of the motion will remains the constant, as no any acceleration due to gravity force acts on that component. Okay, no any force is acting on that component in that horizontal direction. The acceleration due to gravity only acts in a vertically downward direction. So that's why there is no any effect of the acceleration due to gravity on the horizontal component of the velocity. Okay, so in this case also the same concept happening there, the same effect is there, that when the object is thrown from this aeroplane, the initially it is having its own individual velocity, initial velocity of the object. Okay, initial velocity of object will be equal to 0. Okay, initial velocity of the object will be equal to 0, and as within a fraction of second it's will undergo the force due to the gravity. Okay, so it will undergo the force due to the gravity, and that's why we can say here that when the time goes on, it comes under the effect of the acceleration due to gravity, and it will get accelerated. Okay, as the time goes on, it will get accelerated. So if we think about this, then we come to know that if object is thrown from the particular height, suppose we consider that height as the h. If we consider that height as the h, then in that case, suppose the ball is thrown, suppose the object is thrown from this height h, then in that case, initially here the value of u is equal to 0. Okay, value of u is equal to 0, and it's having one component, that is the ux. Okay, and its value will not change with respect to the time, because it will not go undergo any effect. Okay, acceleration due to gravity will not affect this value of the velocity in a horizontal direction. So when we throw the object from this position, what will happen? Initially the object will be at this position, and as the time passes, what will happen? Its velocity in a downward direction increases. Okay, its velocity in a downward direction increases. Now at this point it will be some velocity. Okay, it will have the different velocity. At this point it will have the different velocity. At this point it will have the different velocity. So like this it will come down to this position, and at this position it is having both the velocities. Okay, it is having both the velocities, that is the vy in a downward direction and ux in a horizontal direction, and object will strike on the ground with both the velocities, that is the ux and the vy, with the help of both the components. Okay, so in this case, if we think about the path of the object in a horizontal motion, the horizontal projectile motion, then in that case, if we consider the object, then in that case, suppose we have to find out the velocity at this point, then here will be, it will be undergo the effect ux. Here again it is having the same value of ux, but this value of the vy changes with respect to time. Okay, value of vy changes with respect to time, and it is making some angle alpha with respect to the horizontal. Okay, it will make some angle alpha with respect to horizontal. So in this case, if we have to find out the final velocity when it strikes down the ground, then in that case what is happening there, it will be under the effect of the horizontal velocity, that is ux, and it will be under the effect of the vy, and its resultant will be in this direction. Okay, its resultant will be in this direction, making some angle alpha with respect to the horizontal direction. Okay, so in this case, if we consider the final velocity, then final velocity is calculated as v is equal to, this v is equal to under root of ux square plus vy square. Okay, ux square plus vy square. This final velocity v is equal to under root of ux square plus vy square. So like this, if we have find out the final velocity v is equal to under root of ux square plus vy square, then in that case we have to go by this particular formula. Okay, so some examples of the horizontal projectile motion are, if in some floody area, suppose we have to give some help with the help of the aeroplanes, then we must understand this projectile motion, this horizontal projectile motion, because when we throw the packets, the food packets from the aeroplane from the sky, then at that time the food packets must reach up to that people standing on the earth's surface. It will not go anywhere here and there. So in that case we have to think about the horizontal projectile motion, and accordingly we have to throw that particular food packets. Also in case of if we consider when we have to throw a ball, then in that case if we have to throw a ball up to that particular boy from your gallery, then in that case you have to manage that particular angle, and accordingly you are throwing that ball, and then only you are indirectly going for the horizontal projectile. Okay, so in this case what we have to do, if we have to find out the time period for that particular horizontal projectile motion, then in that case what is the time period, how we can calculate that time period of the horizontal motion, that is the important, and accordingly we have to throw that object. Okay, so what is the distance the object has to cover here? It is nothing but equal to the height h. Okay, so here s, height h, height is equal to h is equal to distance to be covered. Okay, equal to distance to be covered, it is equal to s. Okay, equal to distance to be covered, it is equal to s. Now the velocity, initial velocity is equal to u, then time period, it is equal to t. Okay, we have to find out this, and acceleration is equal to acceleration due to gravity. Is equal to g. Okay, acceleration is equal to acceleration due to gravity is equal to g, because the motion of the object under the effect of the acceleration force of the gravity. Okay, so that's why our acceleration becomes acceleration due to gravity, that is equal to g. So in this case, if we have to find out the time period, then we have to use the equation of the kinematics. Okay, so if we use the equation s is equal to distance, s is equal to ut plus 1/2 at square. Okay, this is the equation of the kinematics. Then if we put the values, what is the distance s we have to cover, it is h is equal to, what is the initial velocity, u is equal to 0. Okay, it is equal to 0 because initially the object is at rest. Okay, object is at rest, its initial velocity is 0, so it will be 0 into t plus 1/2 a is equal to g into t square. So it will give us the value of t is equal to twice h upon g. Okay, t is equal to under root of twice h upon g. This is the value of the time period the object will require to cover the horizontal projectile motion. Okay, this is the time period of horizontal projectile motion. Okay, this is the time period for the horizontal projectile motion. So this is the time period for the horizontal projectile motion, and if we have to go for finding the range, okay, if we have to go for finding the range, then the range is nothing but the distance. And how to calculate the distance? Distance is equal to velocity into time. Okay, distance is equal to velocity into time. So what is the velocity here? It is equal to the horizontal velocity. Okay, it is equal to the horizontal velocity. So the range is equal to horizontal speed into time. Okay, so range will be equal to under root of horizontal speed, that is ux, into time period, that is under root of twice h upon g. Okay, that is equal to the range. Okay, it is nothing but equal to the range. So in that case, ux into under root of twice gx will give us the value of the range. Okay, and if we have to find out the value of the velocity at any instant along this horizontal projectile motion, then we can find out the value of the any instant, that is the vertical velocity uy is equal to ut plus 1/2 gt. Okay, we have the value of the velocity as v is equal to u plus at. So u plus at is equal to u plus gt. Okay, we have a value of u is equal to 0 plus gt. Okay, we can write that vy is equal to gt. We have the value of vy is equal to gt. So in this case, we can find out the value of the vertical component vy is equal to gt. And if we have to find out the value of the velocity, that is the final velocity at that particular instant, then we have to go by this particular equation, that is v is equal to ux square plus vy square. Then in that case, v is equal to under root of ux square plus g square plus t square. Okay, this is the final velocity. Okay, v is equal to under root of ux square plus g square plus t square. This is the value of the final velocity in the projectile motion. So whenever we have to go for the horizontal projectile motion, we have to think that the vertical component of the velocity goes on changing for that particular object, but the horizontal component will remain the constant, and accordingly we have to go for the action, okay, such that that food packet must reach on that earth surface, on that up to that people on the earth surface. And also we have to remember that how to calculate the particular velocity, so that we can get that value of the particular velocity. And if we have to find out the direction, so what is the equation for the direction? That is the tan of the angle alpha made by the resultant with respect to any angle, any vector. Okay, so in that case, if we use the alpha, that is to find out the direction, how much will be the angle, we just have to take the tan of the velocity, that is the alpha. Here it is the angle made by the resultant with respect to the horizontal. So here the alpha, that is the direction, is equal to tan inverse of opposite, that is the vy upon ux. Okay, this is the value of tan inverse of vy upon ux. This will give us the value of the direction, and accordingly we have to go for that particular horizontal projectile motion.